Yeah, Rishabh, you want to move the screen? Just go to the next slide. Just we can check what was slides.
Vijay, I'll make you the host.
Yeah, slide 7.
Well, that's just a PPT, so I presume it shouldn't make much of a issue.
Yeah, you are on mute, I guess.
No, no. Is it audible, sir? Probably. Do I have to put a mic or something? Am I audible,
Yeah.
sir?
Yes, yes.
Okay.
We'll wait for some more minutes. We'll start 7 to since we will allow participants to join.
Sure. So it's still 7:45, if I'm not wrong, right, sir?
Now, you can just go up to 7:50, so 7:52. So that we will leave like 8 to 10 minutes for Q&A.
Okay.
During the course of the time, participants are muted because at the same time we will have a YouTube live streaming as well.
Okay.
So we will make them to be muted till 7:52 or 55. 7:50.
So
Then,
basically, that's not an interactive session. So that's what you're trying to tell
yeah,
me. Yeah. Okay.
if you want, we can make it as interactive. But
No,
the
no.
point is, every time they will just unmute, then they will not mute it properly. Then it will
Yeah.
be a disturbing one.
There's always some
But
sort of
you can
background noise that will
encourage
be.
people to use the chat box to answer your questions and so on. So people will be doing, right? And then at the end, we can just curate the questions and you can look at the chat box and answer.
Sure. How's the audio output, sir? Is it fine, or do I have to
Yeah,
put a
fine,
mic or
absolutely
something?
fine.
Okay, great.
Absolutely fine. Yeah. Shall we start?
Sure. Yeah.
So good evening, everyone gathered here for the day 4 of this MCC Research Colloquium series on digital humanities. We have been learning a lot in this series right from the beginning. What is digital humanities, and from different perspectives. We have day 1 with Dr. Phoebe and day 2 with Dr. Selena. And yesterday we have witnessed a lot of other things, especially how to handle the data, the big data analysis and so on from Professor Ramla. And today we have with us Rishabh Antosh from VIT Chennai. Thank you very much, sir, for accepting our invitation and being here to express your expertise here in the computational text analysis in English literature. The thing is that he's from Department of Physics. So that's truly make this particular series as an interdisciplinary one. We have people from English, physics, history, philosophy, computer science, and so on. So we would love to hear it from a scientist in this aspect, how to do the text analysis in English literature. And we are so grateful for the speaker because he's the only speaker that is from outside of MCC in this particular series. Thank you so much, sir. And we don't want to waste your time.
Thank you, sir. So before I would like to begin, I would like to thank MCC for this opportunity and Dr. Vijay Solomon, sir, for this lovely introduction, so to say. Again, a brief intro about me is that I am an alumnus of MCC. So I did my undergrad and postgrad in physics between 2014 to 2019. And I do have my company 5 Angstrong startup at MMIP. So in all ways, MCC is sort of close to my heart. So it feels special to again come back to MCC and then contribute something to the institution back. So with this, I'll move on to today's lecture, which is related to computational text analysis in English literature. I'll give you a quick overview of what we'll look into this particular session. So I have split the whole session into 4 sections. Basically, the first section is about pre-processing. Of course, I did attend few lectures in the past, like the previous sessions. So there was a bit of shade was given on pre-processing, but this is slightly different in that aspect because we'll dwell into 4 or 5 more steps in pre-processing, like cleaning, normalizing, and tokenization, lemmatization, and finally you will get some sort of structured data that where you can sort of immediately see some sort of intuition out of those words. And the section would be about sentiment analysis and hypothesis testing, where you would essentially see all the text, so to say, literary text being converted into numbers, and those numbers would essentially give you some sort of scores. That scores would eventually tell you whether the mood is on the positive side or the negative side. Of course, Ramla ma'am yesterday again shed few light on this, but I would like to give you an overview of the algorithm itself, like how the overall system works, and then we'll move on to some sort of hypothesis testing, because as I see the overall audience is from the research side. So I would like to start with how the hypothesis is formed and how do you test hypothesis, and then how do you infer your outcomes. The third section would essentially be on the machine learning aspect of it, where we do have a broad classification of supervised and unsupervised learning. The third section would precisely focus on supervised learning, where you sort of have labeled data, and then I will explain how to extract certain meaningful features out of the labeled data. And then how do you train a model, and how do you evaluate it, how do you judge it? All these things will be narrated in the third section. And the final session would be about unsupervised, the latter part of the machine learning, which is the unsupervised learning, where I would precisely talk about topic modeling. So to say, it's a project. So where we would sort of group all these texts into meaningful clusters, and then is it possible to infer some sort of meaningful outcomes out of that particular clusters, is what the whole motto or objective of that particular section is going to be. So with no further delays, I'll move on to the next slide, which will give you an overview of the data science workflow. Basically, when you talk about the realm of data science, we do have three broad classification. One is dealing with direct data. Like by data, I mean that with numbers, like the weather data or any data that comes from the machine, or by machine I mean that some sort of mechanical oscillations or something. The second part is where you deal with some sort of image. So there's a different category of data science that deals with image analysis, and third category that is where the natural language processing lies in, where you sort of take text and then you sort of extract meaningful numbers out of it, and then you infer the objective out of it. So the overall pipeline is that the first step is to scope the project. Basically, what do you mean by scoping a project? So you come with a hypothesis, or you come with a motive or an objective, so to say. And then with that objective, you start moving to the next section, which is gathering data. So by gathering data, I mean that it has to be related to your objective. So by data, you mean that all text is going to give you some sort of meaning. So if at all you have an objective in your mind, then all your data that you're gathering has to be directed towards that objective. That's the fulcrum of whole data science. Now here comes the third part, which is cleaning the data. So of course we'll be dealing that in the next slide, but after that comes the exploration of data, which means like visualization and other stuff. I presume a lot of that has been talked about on day 2, if I'm not wrong. So using Vion tools, using basic Python tools like trends and multiple line plots, bar charts, all these two. I presume you would have learned all these things in day 2. So I'm not going to touch upon the fourth step, which is the exploration of data. Of course, the fifth aspect is where the modeling of data takes place, where I was talking about the machine learning, sentiment analysis, unsupervised learning. All these things comes under the fifth step. The final step is where the human intervention kicks in, where you sort of infer your meaningful insights out of the results that you've got out of the machine. Now, with this essence, now you would have got a vague idea as in like where the cleaning or text pre-processing might lie. That's the third step. So you might wonder, like, why am I actually directly jumping into step 3 rather than starting from project? But because the idea is that irrespective of what your objective is, your text pre-processing is going to remain invariant across all sorts of analysis. So that's why I wanted to sort of keep that in the first cadre, so that we make that thing clear. Then it really makes our life easier to sort of move on. So let's go to the first section, which is about text pre-processing. Yeah. So before dealing with text pre-processing, we first have to even answer this question, like, why do we have to clean data in the first place? So this is a very important question in my perspective, because that's something that's going to sprout out of your mind. Because when you sort of read a book or read some sort of literary text, so to say, the immediate thing that you would realize is that the author would have written that particular text in a beautiful manner, and you would have understood the nooks and corners of that particular text. And why do we have to pre-process it? That's where we are a bit murky about. The quick answer is that by cleaning, we don't say that the overall narrative of the author is bad. We are just telling that we are just putting a mask or screen such that we filter certain words out, so that the meaningful words stay so to say, the semantics, meaningful semantics stay, so that the machine can make meaningful insights out of it. So that's what I mean by pre-processing. So you don't have to mistake that, okay, the text might be murky or unclear. No, it's not that sense. So what I'm trying to say is, can we filter out certain meaningful words out of it is what I'm really interested of. So you would essentially know what I try to insist here, if at all I clear this particular slide. So the first step is stopword removal. The goal is to remove grammatical background. So on a vague note, it might look again murky in the sense that why do we have to remove grammar? So before answering that question, we need to understand that essentially language. Because now that we have English as the lingua franca, so I am taking English as our case study. So if at all you take English, so you do have two broad classifications in that. One is function words, the other side of it is the content word. So what are content words? Content words are the ones that actually give you some sort of meaning. Like say for example, if I have to talk in terms of the grammar, then I have to talk the nouns, the verbs, adjectives. All these things would essentially form the category of the content words. Now let's go to the category 2, which is the function words. Function words are basically nothing but like adverbs, pronouns, and other frequently used words like I, you, am, is, and other stuff. So basically what I'm trying to say is that if at all we could remove all these grammatical words like and, to, of, as I said, like punctuations, prepositions, so to say, articles like the and other stuff. If at all I could remove all these things, I can immediately filter out the signals, or so to say, the meaningful words out of a sentence. So if at all you go back and then see this example, which is quite famous sentence, opening sentence of Pride and Prejudice, which goes by, "It is a truth universally acknowledged that a single man in possession of a good fortune must be in want of a wife." Now, what happens if at all I remove all the stop words? So now the same sentence is transformed in such a manner that truth universally acknowledged, single man possession, good fortune, want wife. Of course, it might irk you a bit, annoy you a bit in some sense, because we are not used to reading words without the scaffolding. By scaffolding, I mean that the grammatical words that form the basis. So it might look annoying, but for a machine, this is doing a world of good, because for machine, all these words do not see the word it is do not carry information. Truth, so does truth universally and acknowledged. So if at all you could remove all these words that form the grammatical aspect of it away, then you would eventually get the other words, the meaningful words like truth universally acknowledged. So if at all I go to a literary person, and then if at all I go and ask, just putting this sentence alone, the filtered sentence alone, and then I ask you, what is the social theme of it? So what is the tone of it? So you would immediately be able to answer that, okay, there's possession there, there's fortune that's there, there's wife, man. So all these are social themes that are going to be playing around this particular play. So am I able to decode all these things? Yes. So I really want my machine to just stick on to these words rather than focusing on the other words like it is. Let's take the letter A for that matter. Just look how many times it has been repeated in that particular sentence. 1, 2, 3, and 4. So let's assume that just the fact that you have learned or doing all these word frequency analysis in day 2, if at all you do a word frequency analysis, you would obviously see the the letter A being repeated 4 times rather than the other themes being reflected on where you are really interested in. So if at all I could remove these other scaffolding words like it is out of the equation, then I would immediately be able to see that the other relevant themes that reflect the emotion, the theme, then other stuff immediately kicks in. So that's what I'm trying to say by removing stop words. So next comes the noise removal part. So what I mean by noise here now. So by noise, I mean that there are quite a few artifacts that stay within the digital. This when I talk about noise removal, I precisely pinpoint to digital text because I was there in the previous session where Ramlaman was also talking about Project Gutenberg, where it's a digital archive. You can get all the textbooks out of it. So if at all you download any sort of textbook, let's take Frankenstein for that matter, you download Frankenstein book TXT from Project Gutenberg, and then you would immediately see that the first paragraph will be about Project Gutenberg and the licensing part. And if I'm not wrong, the copyright and other stuff, all the digital footprints or metadata, so to say, metadata. What's metadata? The data about data. So how is it preserved? So which year it was done, and what copyrights they were doing, and all these things. Are these relevant to the novel or the text that we are decoding? No, it doesn't make sense. So what we do is the first and foremost thing is to remove all these data, which means all these licensing part, the publishing things, and the details about the publisher. All these things has to be removed. The stage direction, sometimes these stage directions will be there while the author wouldn't have intended to write, because these stage directions would have been added in some sort of formatting, because it might help the readers to some sort of arrange some plays or something. But did the author intend to write that? If the answer was no, then you have all the rights to sort of delete it. So the essence of noise removal is that this particular line, so it removes the text that was not that was never part of the literary voice. By literary voice, I mean that the author's voice. Okay, so with this, I'll go to the next slide, which immediately give you an outcome of what I was talking about in the previous couple of slides. What I did here was, since you are familiar with, you would be familiar with word cloud. What I've done was I downloaded Frankenstein textbook, and then I created a word cloud out of Frankenstein textbook. So I filtered the first 75 most frequently repeating. If for the audience who do not know what a word cloud is, it's very simple. So it basically filters out the most frequently repeated words. So, and you might wonder why these are arranged in a different orientations, like vectors, and why are they or of different sizes. Basically the size is directly proportional to the frequency. So basically I do have certain words like the and being on the larger side, which means these have been repeated more number of times than the other words which are of the lower cadre in terms of size, so to say. Now if at all I look at this raw text, and then if at all I look at the word cloud of this raw text, do I get any sort of meaning out of it? Is it possible for me to get the emotion out of it, the theme out of it, the tone out of it? No. All I could see is and the of, which often appears in every other text. Now what I will do is I'll apply my first step, which is stop word, and then I'll remove all my grammatical and frequently repeating words. Now I'll immediately be able to see that I can see the other important characters, the nouns, being reflected in this particular word cloud. Like Elizabeth. Elizabeth was a repeating character in that particular novel, or so to say text. There's man, there's father, there's life, death. Of course, we all know Frankenstein often talks about the different facets of life, the death aspect of it, and the life of it, and so many different sinusoidal waves pass through the whole narrative. So all these are immediately reflecting here the moment we remove the stop words. Now, uh, are we missing something? Do we have other words that's been reflected? Yes, we do have something called as project. We do have something called as Gutenberg that's also repeated. These weren't intended by the author to be written, but since it was downloaded from the digital archive from Project Gutenberg, we do have this footprints being left on every single time on a recurrent basis. So we do have this appearing on the workflow. So what I would do is I go to the step 2, do noise removal. Basically, I take these words and put as filters, and then take these guys out of the equation. Now I would the final outcome, you would realize that all these other digital metadata has been removed in the final outcome. Now, it is my due responsibility to also introduce a critical warning that not all frequently repeated words can be added as stop words. For example, take the sentence, I am not happy. Now, the moment I remove all the frequently repeating words like I am, not, was, if, and other stuff, now what I'm left with is just happy. Now, you might want to see that is what you've been lecturing for the last couple of slides, and now you're saying don't remove all the frequently repeated words. So, why are you contradicting your own statement? See, the rationale is that now, not the word not might repeat often, but it does have a specific role to play. Because if at all you look at this particular sentence, even from a humanly perspective, you would immediately see that I am not happy tells you that I convey a negative connotation through that. The moment I do a stopword analysis and then remove the frequently repeated words like I am and not also sometimes fall as frequently repeated words. Now all I'm left with is happy, which immediately flips the humanly perspective, or say the literal meaning of what the sentence was trying to convey. It says I'm not happy. Now you see that it says happy, which is exactly the opposite of what the sentence was supposed to be conveying. So now here comes the humanly intervention where you sort of be mindful of what you remove. So now you have to see, I have to retain certain words like not, never, no, but. See, the word but can also be called as or say categorized as frequently repeated word category. But you would immediately see that whenever you see all these words, the first half of the sentence might convey you something. The moment the word but enters, the other sentence will have a flip side of it. So the emotion will be exactly flipped whenever you have the word but. So what's important is that, so we have to be mindful of what we are removing of. So in my opinion, I would immediately say, especially when you're dealing with literary text, where you it deals with a lot of aesthetics, where you deal with the double negations and so many other things would be written just for the rhythmic sense. So in that cases, I would encourage the users or practitioners to retain certain words like not, never, no, but, although these guys fall under the broad category of frequently used words. Now, here comes the next step, which is the tokenization. Again, I would say this also forms the fulcrum of, so to say, natural language processing, or so to say, even the modern GPTs, like, so to say, large language models. Why do you say this? Because the idea is very simple. So basically, you have a paragraph. So it dissects all these things into lines, sentences, and so to say minimal form. Like this is like what's a minimal thing that you can go down. So you can go from molecule to atom to the other individual parts, then to quarks, and so many things. So I'm just talking in terms of words. So word is a minimal scaffolding or minimal stone that you can have. So you can't dissect a word into anything. So that's called as a token. So a token will eventually is nothing but any sort of word that's been differentiated with a space. So that's how we write words. No, when you write I am selling lemons today. So selling and lemons has to be separated with a comma. So that's how words are written. So a token is recognized that way. So each word contributes to a token. So if at all I take the sentence and then put it to this library called Spacey, it will give me 5 tokens. Now, you might again be questioning me that, okay, so I could see there are four words. I am selling lemons today, but how did you end up getting five? So that's why I said use this library called Spacey in Python, because now this Spacey is capable of recognizing all these apostrophes. So whenever you have this apostrophe, it means that the word has been shortened. So I and am are two different words, so it will take us two tokens, I as separately, m as separately. Selling lemons today, other things are quite intuitive, but I and am are, can be taken as two different words because it's been separated with the apostrophe. So Spacey library is quite intelligent enough to sort of recognize all these things. So we come to the other section, which is lemmatization. This step basically reduces all the words to the base form. So what do I mean by base form? So if at all you have the word running, so it can be reduced to a base form of run. So was will be reduced to be, lemons will be reduced to lemon. So a better example that I could immediately think of is like, uh, if at all you have words like happy, then happier, happiest, happiness. Okay, repeating in the text, Frankenstein for that matter. Now, for a human, it's very easy to understand that all these four words mean the same. The word happy. But for a computer, it becomes very difficult because it treats all these as strings. So the word happy has just 5 letters. Now your happier will have different set of letters. Then happiest does have different set of letters. Happiness have different sets of combinations of letters. So all these are different words. So if at all you do some sort of word frequency analysis, you would eventually see that there'll be 40 counts of happy, 44 counts of happier, and happiness will be repeated 20 times. But what you would essentially want is that all these have to be combined to a single bar graph, where you would see you should have happy being on a higher note. But that doesn't happen because the machine doesn't know what the word mean. So what do you do? So when you do this step called lemmatization, it reduces happier, happiest, happiness to the base form of happy. So immediately it brings all these broad categories or variants of happy to a broader section of happy. Now it's very easy for us to immediately see the tone, or so to say the theme of the text. Now here comes the next part, which is normalization. It is nothing but reducing all the spellings to a base form, in, or say, so to say, the standard form. It starts from the British and American English. So if at all you have two different dialects, then all these things will be shortened to a particular standardized notation, and some Gen Z writing of beauty, like BEA. TIE, then that will also be converted into beauty. That's how all your social media texts are being analyzed. Because whenever we sort of put some sort of comment on social media, like on FB or on Instagram, we don't write the general standard form for some weird reason. But how do you do some sort of analysis on all the texts on social media that's been posted? Let's assume that you are doing some sort of movie review analysis, and then you want to see whether the overall responses from the audience is positive or negative from a platform or web platform. So each one would have his or her own way of writing. Then all these words won't mean the same. So if at all you use this normalization, it would standardize all these spellings and writings to a standard notation. But the trade-off here is that you would immediately be removing the archaic words. By this I mean that let's assume that you're doing some sort of analysis on some biblical text, like some King James version of a biblical text, so to say. Then what you would immediately realize is that there'll be words like thee, thou, and other following words. Now all these words will be converted into the base form, or so to say the standard form. But what's the consequence that we face is that we are essentially missing the timeline. So if at all you don't see thee and thou, I essentially leave the imprint that's leaving on the text. So immediately, if at all I give you the textbook that has all these thee, thou, it's very easy for me to understand that it's either has to come from that era or it has to be a biblical text. But if at all you're converting that to a normalized version of it, then you are actually taking that imprint out, and then you're taking that particular timeline also out of the equation. So that becomes a bit of a trade-off. So again, be mindful of what you do. So I'm giving you all the critical warnings for all the steps, because it's especially when you do or deal with literary texts, it's always essential that you are mindful of all these things, because everything is not mandatory, and it's also domain specific, and it is also your objective specific. So be mindful of that. So we have come to a end of the first section. So I'll quickly give you an overall summary of what we did. So we did stop word removal. What does it do? It removes common words, grammar words, all the frequently repeated words. Why does it matter? Because it immediately reflects the themes, emotions, and the overall social aspect of the text. Next comes the noise removal, where you remove the metadata while it retains the literal meaning of the text. Like you remove the words like project Gutenberg and licensing, publishing rights, and other stuff. So here comes next comes the tokenization, where you break down the whole sentence into smaller chunks like bread loaves, where each word constitutes to something called as token. So this helps you do some sort of analysis, because basically what we are doing is word frequency analysis and other stuff. So basically we need words to be given in some sort of chunks. So next comes the lemmatization, where you reduce all the words to the base form. And what does it immediately give you? It groups all these words into a common parent word. So as I told you, like for happy. So next comes the normalization, where it standardizes all the spellings and it ensures consistency. And from here, you would, by the end of this section, you would have raw data being converted into a standardized text. So that's the overall output. So from here, we'll move on to something called as sentiment analysis and hypothesis testing. I know you would have dealt with this in the previous section a bit. So I would like to rush this out, because we are almost half the way through of the talk. So I do have some half an hour left, I presume. So I would slightly like to rush this particular section. So what is sentiment analysis? So basically, is it possible for me to sort of get the or say derive some numbers from the sentence? That's what we are doing from sentiment analysis. So if at all I give you some certain sets of sentences like this novel changed my life. So would you rate it as positive or negative or neutral? You would obviously state it as positive. The next sentence is like the plot is disappointing. So you would rate it as negative. So how are humans able to understand this? So basically what we do, we look at a sentence and we filter out certain keywords. Like for the first sentence, we do see the word changed. So changed often goes as a positive connotation. So the second on the second sentence, the plot was disappointing. The word disappointing means that it's on a negative note, so it gives you a negative vibe. So if at all we can actually model all these words and then give some sort of numbers to all these words, then we'll also be able to immediately generate some sort of scores to all these words. So that is what we are also trying to do in sentiment analysis. What they do is they take all these emotional words like love, hate, joy, fear. So they assign some sort of score. Let's assume that the word good will have a score of 1. The word very good, the moment you have the prefix very, now your good will be multiplied with a factor of 0.1 with the actual value of good. You get the idea, no? So basically if at all we could assign numbers to this, and then we can do some sort of analysis or say some number play with all these words, then you would immediately be able to understand what the overall sentiment of the sentence is. So basically what we can do is count the number of positive words, count the number of negative words, and count the number of punctuations, count the number of intensifiers like the words like very, extremely, and so on. So what I would like to do is I would like to introduce an algorithm, or say a dictionary based algorithm called as Veda, which is nothing but balance, aware, dictionary, and sentiment reasoning. What does it do is it's basically rule based. So as I told you, each word is already pre-assigned with some sort of value. So now if you have a sentence, each word, the particular value will be added on a continuous basis. It will be swept from left to right. If at all you have something like, let's assume that I do have the word good, if it's written in caps, because that's what you see, whenever you write some sort of review for movie, you won't write the movie was good. Sometimes when you are excited, you would say, bro, this movie was way too good. And that the word good would be in caps, which means you're trying to tell the community that it was way beyond your expectation. It was not just good, it was good. So how does weighted algorithm sort of understand this? Again, by assigning values. So if at all you have punctuations next to some sort of value, next to the word, again you can add some sort of weight to it. Again, if at all if the word is written in caps, again add some sort of weight to it. If at all you have some sort of negation, again it will have a negative weight to it. So that's how the overall structure is being formed. So if you essentially, what happens is the algorithm sort of adds all these scores for each words along with the intensifiers, along with the punctuations, all these things, and then you will get the final score. And that score will be a normalized score, which means it will always be bound within -1 to +1. Because if at all you don't have some sort of normalized score, then your value would shoot up to some arbitrary big number like +46, +100, +1000, depending on the sentence size or depending on the paragraph size. So how do you know which number signifies the maximum intensity of positivity or maximum intensity of negativity? That's where the idea of normalization kicks in, where you sort of limit the whole idea. Basically, by normalization, I mean that you take that overall score and then divide by the root of squared of that particular word plus some alpha. Basically, that particular alpha is a constant, and then people might tend to choose a number of 10 to 15. That's what the literature says. So we don't have to dwell too much into that, but if at all you want to have a flavor of how things are constructed, that's how it generally is being constructed. So basically, whenever you would some sort of score for sentiment, so it basically ranges from -1 to +1, where you go from -1 is of higher negativity, and then the positive one is of higher positivity. And if it's 0, it means the overall tone is neutral. Now here comes the outcome. So I have taken a sentence: when life gives you lemons, and you make lemonade, and you have exclamatory mark over there, you have some sort of emoji there. So all these emojis do carry some sort of marks too. So next comes the next sentence: how dangerous is the acquirement of knowledge? There's a word called dangerous, so it's always going to be on the negative side. Of course, all these exclamations, if at all I would like to pass on the code. If at all I have time, I will also showcase you the code. As you type more number of exclamatory marks, the amount of negation, or say negative score that you get keeps increasing on the negative side. If at all you have 5, 6, 7 exclamatory marks, it will be on the -0.8 or something. Okay, so what's hypothesis? So basically, any claim without any supported data is hypothesis. So how to do some sort of hypothesis testing with this sentiment analysis? That let's take some question. Basically, does the mood of Frankenstein text become darker towards the end? So the hypothesis is that later chapters have negative sentiment score. How do we test that? Basically, we take the hypothesis generated that the later part of the text moves onto the negative side. So step 2 is to group text. So what we do is we take the early chapters and then the late chapters of Frankenstein. We split them into 2 sides, or say 2 categories, and then we apply sentiment scores for this, sentiment scores for the other later part, so the former one and the later one. And then what you would see is that if at all the average sentiment score for the first early chapter is 0.1, the late chapter is negative 0.4, it means that as it goes to the later chapters, it is tending towards the negative tone. Your hypothesis is true. Of course, what I'm talking with respect to hypothesis testing is on a very, very elementary and surface level, because it involves p-testing, t-testing, t-test, and so many other tests. So it's way too complicated. I'm just putting you on an elementary level what you can do with the sentiment scores. So is your hypothesis supported with the data now that you have got? Yes. Now, early chapters average score was 0.1 doesn't mean that it's good. It's on the neutral side. So I'm just giving you that aspect too. So I would like to end this particular section. So this we dwelled upon on the sentiment analysis, how we can convert all these sentiment into numbers, and then we were able to see how the weighted algorithm sort of gives some sort of numbers to it, and how weights have been assigned, and how overall compound score is constructed, how normalization works. All these things we have understood. We just saw how hypothesis can be framed, how to test your hypothesis. You basically take a model and then you back it up with your data. Then you basically claim your hypothesis and then put your data to it, and then infer that basically whatever I have proposed is true. Now we'll move on to section 3, which is actually the important section of the whole talk, where we are talking about the machine learning part of it. So basically, as I told you in the first slide, or so to say the second slide, the broader aspect of machine learning is split into two categories: supervised learning and unsupervised learning. What do you mean by supervised learning? By supervised learning, I mean that I give some sort of data, so to say labeled data. What do I mean by labeled data? By labeled data, I mean that if at all, let's put things into layman terms. I have a objective in my mind. Basically, I want my model to classify a set of data, or say images of dog as dogs, a set of images as cats, and then before I want this model to do that, the model needs some sort of data to train on. So basically, I take some sort of dog images, and then I label them as category 1, or say category dog. And then I take some sort of cat images, and then I label them as category cat. Now, all these are called as labeled data because you have labeled it. Category 1 as dog, category 2 as cat. Now, your machine learning model will try to extract some sort of features out of that category and this category, and then see what is the feature that is sort of separating these two species into two categories, like the dog and the cat into two families. Now, the model at time can struggle to find those features because the model do not know what to look for. Because let's go back to the same dog and cat category, because both the animals do have ears, do have tails, and do have 4 legs. Then how is the model trying to figure out? Now here comes the humanly intervention. You help the model to look for certain features. Like, say, look at the size of the animal. So it has to be slightly bigger. Then it can be categorized as dog. Then look at the teeth of it. So these are certain features that we know. Then you have to teach the model what to look for. So this is exactly what we are doing in supervised learning. So I'll immediately tell you with the terminologies. Now I told you what is training data. What is training data? Text with known labels. In our literary analysis, let's assume that we are given with the task of classifying 2 texts from 2 authors. Let's take Charles Dickens, and another guy can be Jane Austen. You do have certain sets of books that's been written from Jane Austen, and certain sets of books that's coming from Charles Dickens, and then you're training your model to sort of distinguish or demarcate these 2 categories. Now, your model of choice can be anything. I don't want to dwell into again the intricacies because there are so many models available. The basic thing can be naive bias, anything like LR model can also be, logistic regression can also be chosen. So and finally you go for the prediction. So let's go step by step. As I told you, I have 5 books of Jane Austen. I have 5 books of Charles Dickens. I want my model to learn the features first, what to look for. So how to tell the model what to look for? That's where we do something called as feature extraction, or so to say, the text to features transition. So that's what we start by asking, what should I look for in these texts? So now what I am going to tell the particular model is that, please look at these 5 categories alone. Average sentence length, word length distribution, function word frequency, punctuation usage, vocabulary richness. So each author has some sort of stylistic pattern when they write. So the see, I might be wrong in this sense, because you might be familiar with so many different authors, and you might say, okay, no, these set of categories might not essentially be giving you some sort of signature about an author, but maybe with my limited knowledge, I think these are the 5 features that I can look for and then make the model learn. So if the average sentence length is slightly shorter, then it might be falling on category 1, maybe Charles Dickens and so on. So what I am trying to do is, if at all you have some other idea, you can also add in. Like, that's what I'm trying to say. But what I'm trying to do is trying to fit in ideas. With your expertise in that particular field, what you should do is you should also try to add some more features into the overall schema. Now, I'm going to train the model based on these particular aspects. So I'm going to take 5 books, and then I'm going to make the model extract these features and from the Jane Austen books. And again, I'm going to take another 5 sets of books from Charles Dickens. I'm going to make the model extract all these sets of features like word frequency and other stuff that I was talking about in the earlier slide. Then I'm going to feed the algorithm this learning pattern. Now, the general pipeline of this overall structure is that you generally split the data into 2 sets, basically training set and the test set. And be mindful that both the training set and the test set is labeled. We just had labeled data. That labeled data has to be split into 2 categories, basically training set and test set. Now you might ask me, like, see, now already we have just 10 books. Why do you have to split that into 70% and 30%? Which means I'm basically splitting 7 books for training and 3 books I'm just reserving for testing. Why can't I just put all the 10 textbooks straight away to the model for the learning process? The immediate answer is that whenever you do some sort of machine learning analysis, you are essentially trying to make sure that the model is generalizing and is also learning the overall pattern of it. But if at all you're putting all your label data as training or for the learning purpose, how do you know the model has learned or not? This is as simple as a student learning something. So a student might learn everything, but eventually when the student appears for the exam, only then you will know based on the scores whether the student has learned the particular aspect or not. The same rule applies for the overall data science workflow also. So that's why we reserve something for training, and we reserve certain small quantity. It shouldn't be as big as 30%. It can be as small as 15 to 20%, depends on the size. In real world, you don't go with the limited sets of 10 textbooks together. It has to be as big as, say, 1,000 to 10,000, as much as books as possible. Now, what happens if at all you do this? Now, at this stage, training set, it will learn all the patterns, and then it will learn, the model will come with a decision. Now, when you put this test set, which is the reserved 3 textbooks that's been kept aside, now it will give you, the model will tell you whether the book is aligned to label Charles Dickens or Austen. Now that you have also the labels with you, you will also cross check whether the model has correctly predicted or not, right? Now it is easy for you to say whether the model has correctly predicted or not. Based on it, you will give some sort of score to it. That's what we call it as accuracy. What is accuracy? How many samples does my model has correctly predicted divided by the total number of samples? How many did we reserve? 3. So I divided by 3. how many did my model correctly predict out of the 3 sets? 2. It has predicted one incorrectly. So my accuracy is that 2 by 3 is 66%. So if my performance of my model, of course, I'm putting it on a vague sense. Of course, you do have some other metrics like F1 score, sensitivity, and recall, and so many other metrics are there. Primarily, people might stick on to accuracy for quick analysis, but since we are dealing with the surface level, so I'm just sticking on to accuracy alone. So if a practitioner has to look or assess a model, if at all he sees, okay, if it's 66%, what he'll do is, okay, the model is okay, so it's doing well, but it hasn't really learned everything. So what do I do is, can I work on the features extraction part? Do I add some more features so that the model can efficiently learn? So how do I improve the accuracy? Why am I doing all these things? Because the moment you're putting a model to deployment, by deployment I mean that I go, since we are talking in terms of research colloquium aspect, so the moment you say, you write a paper and then say, okay, I can distinguish these two categories into two sets, so I am so and so approving this particular paper, and then you put it on the journal, and then the referee would immediately say that, can you just take some sort of new data and then test it, which are not there. So he might suggest you some new books which were not initially been assigned. Now what you will do is, when you test your model on that particular new set of data, your model might falter. Now you will be embarrassed in the sense that, okay, I was claiming something that, okay, my model should be working fine, and it so and so the metrics were really good and something, but now it failed to sort of replicate the same performance. So where did I go wrong? So that's when you have to go back to the accuracy and then see, or go to the test set and then see, did your model perform well even in the testing part? Was your scores well? If the scores are poor, then again you have to go back to the drawing board and then see where you have bent wrong and where you can tweak a bit. Okay, so the final thing is, if at all you're quite satisfied with the model's accuracy and so on and other stuff, then you can finally put your model for the prediction stage, or so to say the deployment stage, where you can take random sets of this data and then see whether your model is able to predict it as Austin or Charles Dickens. So with this, we are winding up this particular section where you have where we learned all the labeling part, features, training, the testing. The simplest way to summarize this is in the form of a flowchart, where you have the label, you have a raw text data, and then you have to label it, and then you sort of extract all these features, and then you take and split them into training and test set, where your training has 7 books, your testing will have 3 books. Based on the split ratio, it can be like 80-20, 80%, 20%, 90%, 10%, depending on the size of the data. And then finally your trained model will test whether your model has learned well or not. Then your evaluation metrics will reflect your model's generalization, and then finally you can go ahead with your model and then go for the deployment stage. That's the overall summary. Now finally we move on to the unsupervised learning, which is the latter part of the broad classification of machine learning. So unlike the former one, where it learns from the labeled data, unsupervised learning has a tendency to learn from the unlabeled data. I won't say it's a tendency, but not always you have the luxury to label the data. Let's assume that I have no clue about what the textbooks are about. The simplest example is that, let's assume that you are a newbie as a librarian, and then let's think I'm just coming from a physics domain, so I do not know anything about what the books are about. So I've been given heavy sets of chunks of data now. I have thousands of books to categorize. Now I do have certain bookshelves that goes by drama, poetic category, and there's romantic category, there's a gothic category. And I have to categorize all these thousands of books into that particular shelf. Now, as a human, it becomes very difficult, because I'm demanding too, because I literally have to read the whole textbook and then see where, okay, this guy might fit in this particular category, this guy might fit in this particular category. Now, instead of doing that, you can do something called as unsupervised learning, where you don't have to sort of have any prior knowledge about the data. You make the model learn the patterns. So now here comes the idea of unsupervised learning. It finds patterns in data without labels, unlike the previous one, like supervised learning, and groups similar items automatically and reveals the hidden structure. Now, the only catch here is that the only input that you have to tell the model is that how many categories or how many groups does the model have to segregate these on? Because if at all I ask you to segregate without giving you the bookshelves, you would be wondering, okay, which categories do I have to say put these books into? Let's say I would say just put I just have two categories in my mind, fiction and non-fiction. Now things become much simpler for you. You would just put these sets of books into this category and that the other part into different category. Similarly, for the model 2, it can find patterns, but you just have to input the model that just how many categories it has to classify or cluster on. So that's the only input that the model expects from the human. Now, how there's something called as topic modeling. That's what we were discussing about. How does it model based on the topics? So there's something called as word co-occurrences. Before doing that, what we have to do is prepare the text. So to do that, I need to follow the text pre-processing that I was talking about in the section 1. All this cleaning, stop words removal, noise removal, lemmatization, and whatnot, normalization, and other stuff. So all these things has to be taken care of. Now, the moment that's been done, now you would immediately put your data into the unsupervised learning model. In my category, I have taken latent Dirichlet allocation. What this particular algorithm does is that it just takes all your cleaned structured data, and then it identifies the co-occurrences of words. Basically, what this does is that the simplest way to explain this algorithm is that it will take each sample by sample in row wise, and it will have different sets of words like say love, happy, sad, and all these words will be in column based. So this is like a matrix. Each sample this way, and the unique words are being segmented in terms of columns. Now what it will do is it will compare how many samples does each word has been. Basically, it's nothing but the word frequency that's been written in form of a matrix. So if at all you construct this matrix, it's very easy for you to identify that all these sets of romantic words like love, pleasing, and endearment words have a common cluster, while the hating words like or so to say the other latter section of the words will come into a different cluster. So that is what, oops, yeah. So let's assume that I give the model that I need 4 topics. So what it will do is, instead of classifying into 4 clusters, it will basically classify into another 4 clusters, local clusters. So basically, words like love, heart, beauty, happiness, hope will be clustered together. How does it cluster? As I told you, based on the co-occurrences. Basically, if at all you have love, you would often see that the beauty would be associated to it, happiness would be associated to it, hope would be associated next to it. So based on how frequently these words are placed next to each other, it would be segmented into a cluster. So based on your input, whether I need how many clusters, do I need 2 clusters or 4 clusters, the topics will be differing. So basically, if at all I say I need only 4 clusters, topic 1 will be essentially giving you words like most frequently repeated words like love, heart, beauty. Second topics will give you war, soldier, death, battle, blood, and so on. Topic 3 will be land, village, river, and topic 4 will be letter, family, and other stuff. Now, this is where again the intervention of human is required, where it will just give you topic 1, topic 2, topic 3, topic 4, because the model doesn't know what these sets of words together mean. But what humans can do is, hey, if at all you can cluster all these guys together, I would immediately be able to label it. See, if you say, for example, this first topic can be classified as romance. The second topic can be categorized into war. Third category into nature. Fourth category into the segmentation of family. So on and so forth. So this is where the human requirement or say human assistance is required. So what's an application of this? So the immediate application is that I was just telling you, that if at all you are a librarian trying to sort of segment all the heavy sets of chunks of books, and you have no clue about what these books are about, then you can immediately try to do these kind of analysis and then try to catalog all these things. Another thing is social media analysis. So what you can do is you can go for analyze some sort of sentiment based or say even topic based discussions, even with respect to political campaign. Say if I come from a political wing A, then I go to the social media and see what the whole discussion is about. And then I'll say there are 2 different topics that's been talked about. Then I'll know, okay, these are the trending things that's been going on. Can I do something about it? Can I campaign something related to that? So this is how all these clubbing, even in terms of industry aspects, is this whole talk is not just limited to the literature aspect of it. You can also extrapolate the same idea to industry aspect of it, where you can deal all these things in a beautiful manner and then get great insights out of it. So why do we need topic modeling in DH? Because it enables analysis of larger corpora and reveals hidden thematic structures, supports exploratory research. So if I don't have to summarize this particular section, unsupervised learning finds patterns without having to label it. So that's a great green signal. And topic modeling groups based on co-occurring words. That's what we were trying to do. That's what we were doing with respect to LDA, that allocation algorithm. And each topic might have different sets of clusters. And how does a topic has to be labeled depends on the humanly insight. So it all boils down to what the humans interpret. So we are in the last section of the whole talk. So I'm just sorry for going way beyond the given time. So I'm just 10 minutes way beyond the time mark. So please bear me with that particular aspect. So if I have to summarize, we learned about pre-processing. We learned how to convert raw text into a structured data. We learned how to do sentiment analysis, how to convert all these data text into numbers, and how to get the compound scores. We learned how to do machine learning with respect to supervised learning. How can we generate label data? How to train the model? How to segment it into training and testing set? How to evaluate the model? So finally, we just dealt with unsupervised learning. How do models actually cluster among themselves if at all they don't have any prior idea or prior labels? And then how is the humanly interpretation required to sort of label the clusters based on the out. So with this, I would like to end the session. I thank the dignitaries, and I thank MCC for giving me this wonderful opportunity to present. And over to the questions, if at all we have something. Yeah.
Thank you, Rishabh sir. Thank you, Professor Rishabh, for a very insightful presentation. That was a very insightful presentation on computational text analysis in English literature, from corpus to preparation to pattern discovery. You have outlined the process of analyzing literary text using digital methods like topic modeling, and emphasized the transition from selecting and building a corpus to preparing the data through cleaning and structuring. So before I give a brief summary, let me invite the participants to ask questions. Participants, do you have questions for Professor Rishabh? And while we get ready with the questions, a feedback form is posted in the chat box. And I kindly request the participants to fill the feedback form and complete it by 10:30 tonight. Participants, do you have any questions?
So I do have a collab that can be projected if at all the participants are interested, or I can also share the link if the participants are interested in working along those lines.
Yes, Professor, you can share the link on the chat box.
So,
Yeah, Rishabh sir, thank you very much. One question is like you have mentioned about the social media analysis.
yes.
If suppose like if you can help us in showing some of the research papers where they have done such analysis using these tools. Probably you can share some papers so that we'll have some model for us to follow, because now we have a lot of data that is like popping up in the social media on a daily basis. Especially you also mentioned about the election process or like the campaigns and so on. So it would be good if a team from MCC can take up some of the real-time problems to work with these tools, so that they will also have some kind of objectives to work with the tools.
Sure, sir. I don't have the literature as of now, but I would definitely be loving to.
Yeah,
provide
you
the
can just
literature.
send it across to the organizers, to Phoebe ma'am. Few papers, such as like model from different dimension. Because as a participants from different domain, we always would like to look at the applications, like where exactly we can apply this. About the limitations that we have with a lot of workloads as a faculty.
Yeah.
So we really want to have some models to just to boost the confidence. Yeah, that's my suggestion. Yeah.
Sure, sir. I'll definitely be loving to do that.
Yeah.
Thank you, sir. Are there any questions from the participants? Dear participants, Rishabh sir has shared the collab link. You can have a look at it. You can copy the link, or the link we can also share it to Vijay Solman sir, which can be shared in the MCC RC group.
Yes, yes.
Are there any questions from the participants? Participants, a gentle reminder regarding the feedback. Kindly fill up the feedback by 10:30 tonight. Every day, at the end of the session, a feedback link is posted in the chat box, and you're required and requested to kindly fill up the feedback form. This is important for, yes, Rishabh sir needs to give access.
Okay.
Professor Rishabh, please give access to the collab link.
Sure. I'll do that.
Yeah.
I'll make
Thank you.
access to all. Yeah.
Okay, yeah. Are there any questions from the participants regarding topic modeling, supervised and unsupervised learning? I think they are very new topics to us. Thank you, Rishabh sir, for explaining how patterns such as word frequency, themes, and stylistic features can be identified using computational tools. Overall, you have highlighted how digital humanities techniques such as supervised, unsupervised learning enable researchers to move beyond traditional reading methods and uncover insights at scale, making literary analysis more systematic, data-driven, and capable of revealing hidden structures within large collections of texts, with very interesting examples. Towards the end, you have mentioned the applications of topic modeling and how integral human intervention is in various stages. This is something that is recurrent, dear participants, if you notice. Through every session, at the end of the session, you've been told constantly that human intervention is essential. We have a lot of tools, digital humanities tools, which makes a process interesting and easy. But at the end of the day, it is a human person who would give the interpretation. So on that note, I would like to thank Professor Rishabh, Assistant Professor from VIT Physics Department, for your time and for explaining to us the concepts of topic modeling in supervised and unsupervised learning. Thank you so much, sir. Thank you, the team, MCC, RC team. I thank you for coordinating it, Vijay Solomon, sir, and Bebin, sir. And thank you so much, participants, for your kind patience and listening. And with that, we come to the end of day 4 of our Digital Humanities series. We will meet again on Monday. Dear participants, it's a gentle reminder that we will not be having the presentations tomorrow or Saturday through Sunday. The next presentation, that is day 5 of the series, will be on Monday. So see you all on Monday. Thank you so much. Have a good